So in this video, we're going to talk about how to divide rational expressions. So the main thing to remember when dividing rational expressions is you have to use that keep, change, flip idea that you learned back when you were dividing fractions. So we're going to need to flip the second fraction and then change the problem to multiplication. And then after that, the steps will be exactly the same as we did when we were multiplying. So you factor everything, cancel common factors, and then you just go ahead and do it as though it was a multiplication problem. So let's look at some examples. So here, you notice that it's a division problem. So the first thing that I would do is just go ahead and rewrite it. So remember, the first fraction is going to stay the same, right? X squared minus 5x plus 6 over x plus 2. Then we change the division to a multiplication, and we're going to flip the second fraction. So we have x squared plus 4x plus 4 over 4x minus 12. Okay, so just like we did in the last video, I'm now going to number everything so we know what we're working on factoring. So I'm going to start off by factoring number 1. And when I factor number 1, I'm factoring x squared minus 5x plus 6. I need two factors of 6 that are going to add up to negative 5. Since 6 is positive, I know the factors have the same sign. Since 5 is negative, both factors need to be negative. So negative 2 and negative 3 are the combination that works. So I have x minus 2 times x minus 3. 2 is just x plus 2, and that does not factor, so I'm going to leave that one as is. Number 3 is x squared plus 4x plus 4. And when I try to factor that, well, I need two factors of 4 that are going to add up to 4. So that's going to be 2 and 2. So this is going to be x plus 2 times x plus 2. And then in 4, I have 4x minus 12. Remember, when you don't have a trinomial, it's good to check for a GCF. The GCF that will factor out of both of these terms is 4. So if I factor out of 4, I have 4x over 4 minus 12 over 4. So that's going to give me 4 times x minus 3. So now let's go ahead and plug in all these factored forms, not into the original expression, right? We don't want to go back to the division. We want to go here, right? So this multiplication, let's go and plug it in there. So I'm going to get, let's see, the number 1 is x minus 2 times x minus 3. And then number 2 just stayed as is. So I just have x plus 2 down here. And then remember, I changed it to multiplication. And so I have now number 3, which is x plus 2 times x plus 2. And then I have number 4, which is 4 times x minus 3. Okay, so now let's go ahead and cancel our common factors. So x plus 2 will cancel. X minus 3 will cancel. So in the numerator, all we're left with is x minus 2 times x plus 2, and then denominator we have 4. Okay, so let me go ahead and write that out. X minus 2 times x plus 2, and then in the denominator we have 4. So if you can leave your answer in factored form, you can do that, or you may see it all multiplied out. So the numerator, notice that that's a difference of squares. So we have x squared minus 4 over 4. Okay, so either form is the correct answer to this problem. So when you see problems like this, it may look confusing, right? Because it looks like one giant fraction. But the thing I want you to realize is what a fraction bar is really representing is division. So this is like one rational expression you see here that I'm highlighting in yellow being divided by like this other rational expression that's being written down here, okay? The one that's in green. So I hope you can see that I can take this problem now and just rewrite it as 3x squared plus 6x plus 3 divided by x squared minus 3x minus 10, and that's divided by the second rational expression, which I have 12x squared minus 12 over x squared minus 4. Okay, so you see that's how you take these giant fraction looking problems and turn them into a division problem, because that's really all that this is representing. So now I'm going to use like my regular division steps, right? So I'm just going to go ahead and rewrite this. I'm going to keep the first fraction as is, so 3x squared plus 6x plus 3 over x squared minus 3x minus 10. Change the sign to multiplication, and then I'm going to flip the second fraction. So I have x squared minus 4 over 12x squared minus 12. Okay, so now we're back to our regular division steps. So we have, number everything so we can keep track of our work. And then we're going to go ahead and just factor wherever possible. So if we look at 1, it's actually pretty interesting because notice that 1 has a GCF. So remember, you always want to be a lookout for the GCF if there is one, right? So the GCF here is 3. So I'm going to start off by factoring that out. So it's just going to make my trinomial, a whole lot simpler, especially when I'm just going to go ahead and factor. So when I factor out the GCF, that's going to leave me with 3 times x squared plus 2x plus 1, okay? So you see that x squared plus 2x plus 1 is actually a lot easier to factor. That's just x plus 1 squared. So this has now become 3 times x plus 1 squared. Remember in your fully factored form to include the GCF. Now let's factor 2. So 2 is x squared minus 3x minus 10. Here I'm going to need two factors of negative 10 that are going to add up to negative 3. So the combination that works is 2 and 5. Remember, since we have a positive and a negative factor, we want the bigger factor to match the sign of b. So we're going to make the bigger factor negative. So this is going to factor into x plus 2 times x minus 5. Now let's go to factor 3. 3 is x squared minus 4, and I hope that by now you recognize that that's a difference of squares, right? That's x squared minus 2 squared. So I can factor this as x plus 2 times x minus 2. Okay, and then now I'm going to factor the last denominator, which is at 12x squared minus 12. Since I'm out of room, I'm going to go to the next slide. So I have 12x squared minus 12, which is number 4. And so I can factor this actually by GCF, right? So notice that these terms have a GCF of 12, so I can factor that out. So it becomes 12 times 12x squared over 12 minus 12 over 12. So that's 12 times x squared minus 1. Well, you want to factor fully, right? You want to be sure and look at your answers and make sure that you factored completely. I can actually factor this x squared minus 1 a little bit further, because notice this is also a difference of squares, so I can factor this as 12 times x plus 1 times x minus 1. Okay, so that is actually the fully factored form. It's very, very important to factor fully because you want to make sure that you can have every factor written out so that you can just cancel wherever possible. So now let's go back to our multiplication and then rewrite all our numerators and denominators in their factored form, okay? So remember, the multiplication that I'm talking about is like this that I've rewritten right here, right? So this is what I want to replace with factored form. So the first numerator is 3 times x plus 1 squared, so that's going to go here, 3 times x plus 1 squared. The next denominator that I had, the number 2, was x plus 2 times x minus 5. So that's going to go down here, x plus 2 times x minus 5. And then the next numerator that I have, that was this x squared minus 4 that factored into x plus 2, x minus 2. So I'm going to write that over here, x plus 2, x minus 2. And then I have finally now my 12 times x plus 1 times x minus 1, okay? So here, this numerator I've written as 3 times x plus 1 squared. I'm going to write that in expanded form so that you can see where I'm canceling things, okay? So what I'm doing is, instead of writing it like this, I'm going to write it as 3 times x plus 1 times x plus 1, because I want you to see what I'm canceling. Okay, so now for the fun part, right? We get to go ahead and cross things out. So the reason I wrote it in expanded form is because now this x plus 1 and x plus 1 will cancel. X plus 2 will cancel, but now let's think about this 3 and 12, okay? So when you have numbers, you also want to kind of write them in factored form. So like this 12, for example, I can write this as 3 times 4. And so I hope that now you see that I can actually cancel the 3 here and the 3 here. So I'm going to go ahead and do that. And so now let's just pick up whatever it is that we have left. So in the numerator, we have x plus 1 times x minus 2, right? Because we canceled everything else. In the denominator, we have x minus 5, and then we have the 4, so I'm going to write the 4 in front because we usually do that with constants, and then we have x minus 1. Okay, so this is your answer in factored form. Sometimes, like I said, you'll have to go ahead and multiply it out, so let's just multiply everything out. So the numerator will be x squared minus x minus 2, right? You can use FOIL there. And the denominator will have 4 times, and then let's see, we'll have x squared minus 6x plus 5. Sometimes they'll leave that GCF in front, but sometimes they'll just multiply everything through by that. So you'll just have x squared minus x minus 2 over, and then if we multiply everything here by 4, in the denominator, that'll give us 4x squared minus 24x plus 20. Okay, so either of these boxed answers is the correct way to represent the answer. Okay, so now you can go ahead and pause the video and try doing this example on your own. All right, here, so it's division. So remember, first step is to keep the first fraction, change the sign to multiplication, and then flip the second one. Then what I did is I went through and I just factored everything. So the first numerator is x plus 2 times x plus 5. That 4 of the denominator I factored into 2 times 2. And then the second numerator, 2x plus 10, that factored with a GCF, so I got 2 times x plus 5. And the final denominator, 3x plus 6, factored into 3 times x plus 2, because there's a GCF there. So here now I have it written out in factored form. So I had the x plus 2's canceled, and then in the numerator I had x plus 5 and x plus 5, okay? It's very important to notice that these don't cancel. The reason they don't cancel is because they're both numerators, okay? So you have to have them on opposite sides of the fraction in order to cancel. If they're on the same side, you have to keep them. That's how I got an x plus 5 squared in my answer in the numerator, and then in the denominator I got 2 times 3, which is 6.